What if your mind could pull knowledge from the net as easily as you breathe? What if illness, forgetfulness, and mortal limits were no longer the final chapter of your story? Tonight we step into a near future where biology and artificial intelligence stop being tools and start being partners, biointegrated AI. Stick with me, this will change how you see yourself. Don't forget to like, subscribe, and tell me in the comments, what would you want your brain to be able to do? We'll come back to that. Humans didn't get this far because our genes were perfect. We got here because we learned to make tools that extend our minds. But biological evolution moves at geological speed. Natural selection is simply too slow for the stakes we now face. Humans didn't get this far because our genes were perfect. We got here because we learned to make tools that extend our minds. Stone tools, language, written knowledge, the internet, each leap widened our cognitive reach. But biological evolution moves at geological speed. In a century of climate collapse, emergent pandemics, and an AI intelligence explosion, natural selection is simply too slow for the stakes we now face. This is the biological imperative. We must accelerate our capacity to sense, compute, and adapt, or be left behind. An acceleration is already happening. Living, adaptive systems that we once thought purely biological are revealing information architectures, memories, and decision-making capacities in ways that blur the line between life and computation. These discoveries change the frame. Evolution is no longer only a slow, blind process. It can be steered. If that thought makes you curious or uncomfortable, drop a fire in the comments. I want to see which side you're on. But biological evolution moves at geological speed. Natural selection is simply too slow for the stakes we now face. We're not talking fanciful cyborg fantasy. Laboratories today are creating hybrid living machines, cell collectives that move, heal, and even make choices within their environment. Researchers have built motile constructs and living, self-repairing microrobots from animal and human cells. These anthrobots and Xenobots challenge the old categories of organism and machine. These are not props from a movie. They are experimental realities that show cells can be prompted, shaped, and even given new behaviors using computational design loops. On the other side of the bridge, brain-computer interfaces, BCIs, are no longer lab curiosities. Clinical trials and commercial devices are beginning to let people control cursors, type with thought, and even restore speech to paralyzed patients. Companies and research hospitals are running trials that feed brain signals into AI decoders, and the AI learns the patterns, translates intent, and sends precise instructions to devices in real time. This is biointegration in action, biological signals interpreted by AI, producing new capability. Imagine instant language acquisition. You think a phrase in Japanese, and your neural interface renders meaning directly into comprehension. Imagine removing the bottleneck of attention, so complex scientific problems become shared group minds, each contributor bringing AI-amplified cognition to a global solution. Imagine damaged tissue repaired by living machines that reprogram their morphology on demand, or molecular systems trained to remember and correct disease states before symptoms emerge. These are not abstractions, they're engineering roadmaps being sketched today. But there's more. Biointegrated AI could transform education, workforce, creativity, and even governance. Think of EEQ, AIQ, and SSQ, emotional, artificial, and social sustainable intelligence, woven into the habits of daily life. This triple engine could make leadership not only smarter, but wiser and fairer if we design incentives around shared benefit rather than exclusive advantage. Here's the uncomfortable part. Not everyone will get access. Augmented people and baseline people could diverge into different social strata overnight. Imagine cognitive subscriptions where companies sell premium thinking, who controls access, who owns the raw neural data, who can be nudged or exploited. An identity. If your memory traces are stored or extended by machine layers, where does you begin and end? These are not philosophy thought experiments. They are urgent policy problems. Then there's safety. Living, adaptive systems are unpredictable by design. We already see examples where simple cellular collectives surprise their creators with emergent behaviors. When you couple unpredictable biological agents with powerful AI that can redesign or scale them, the risk profile multiplies. Governance must catch up, but it's racing against experimentation that can cross borders in a weekend. If you care about fairness here, comment equity and I'll pin the best ideas. Recent peer research shows that cell collectives can change gene expression and behavior without genomic editing, morphology, and emergent life history influence what those collectives do. Labs mapping the bioelectric patterns that guide development have even been able to rewrite the set points organisms use to build bodies, literally changing outcomes like number of heads in experimental worms by altering bioelectric states. These experiments underscore a radical point: information formats other than DNA, bioelectrics, morphogenetic patterns, can store and transmit functional memory. At the same time, closed-loop BCIs that integrate AI for decoding signals are advancing clinical capability, from restored speech to control of prosthetics. Clinical trials are expanding, regulators are watching, and commercial partners are integrating large AI models to make decoding faster and more reliable. That momentum matters because it means biointegration is not just theoretical, it's moving into the lived space where law, commerce, and ethics collide. If this section surprised you, smash that like button. It tells YouTube to put this conversation in front of the people who must hear it. Any technology that augments cognition can be weaponized. Imagine targeted cognitive ads that bypass deliberative thought or neuromodulation used as behavioral control. Consider authoritarian regimes with access to pervasive neural monitoring. The temptation to surveil and shape populations is real. Add biological agents that are programmable, and the scenario space includes manipulation of bodies as well as minds. This isn't designed to scare you. It's to make clear that ethics must be as technical as the engineering. So what guardrails do we need? Transparent data governance, encryption-first neural archives, open safety standards, and equitable access programs are a start. But history warns, regulations trail technologies. Civil society, technologists, clinicians, and ethicists must act now. Design the defaults before someone codes a profitable dystopia. We are at an inflection point. Evolution has always used novelty to expand cognitive light cones. Now we have the tools to intentionally steer that expansion. That agency is a responsibility. We must choose policies and business models that distribute enhancement, protect autonomy, and preserve dignity. So what do you do as a leader, as a teacher, founder, parent, or citizen? First, learn the science. Second, demand transparency and auditability. Third, design for redundancy and reversibility, make enhancements optional and revocable. Fourth, cultivate your EEQ and SSQ, Technical power without ethical maturity is just an accelerant for harm. Think of EEQ, AIQ, and SSQ, emotional, artificial, and social sustainable intelligence, woven into the habits of daily life. Here's the uncomfortable part. Not everyone will get access. Augmented people and baseline people could diverge into different social strata overnight. Imagine cognitive subscriptions where companies sell premium thinking, who controls access, who owns the raw neural data. Then there's safety. Living, adaptive systems are unpredictable by design. When you couple unpredictable biological agents with powerful AI, the risk profile multiplies. Recent peer research shows that cell collectives can change gene expression and behavior without genomic editing. Labs mapping bioelectric patterns have even been able to rewrite the set points organisms use to build bodies. This underscores a radical point. Information formats other than DNA can store and transmit functional memory. Any technology that augments cognition can be weaponized. Imagine targeted cognitive ads that bypass deliberative thought. Consider authoritarian regimes with access to pervasive neural monitoring. The temptation to surveil and shape populations is real. This isn't designed to scare you. It's to make clear that ethics must be as technical as the engineering. We are at an inflection point. Evolution has always used novelty to expand cognitive light cones. Now we have the tools to intentionally steer that expansion. That agency is a responsibility. First, learn the science. Second, demand transparency and auditability. Third, design for redundancy and reversibility. Fourth, cultivate your EEQ and SSQ. Technical power without ethical maturity is just an accelerant for harm. We've walked through living machines, neural decoders, emergent cellular intelligence, and the moral minefields ahead. Here's the cliffhanger. In my next video, I'll show 3 real protocols you can use to assess whether a BioAI project is safe, ethical, and scalable. And I'll walk through a case study of an early clinical BCI trial and a Xenobot experiment side by side. Which case study do you want first? The implant that restored speech, or the living machine that self-heals? Vote now in the pinned poll, and I'll pick the winner for the deep dive. This is not apocalypse or utopia. It's co-evolution, imperfect humans building powerful tools that in turn reshape us. We can refuse to be passive. We can design augmentation that amplifies empathy, extends stewardship, and democratizes capability. If you felt the chill, that sense of both fear and possibility, you're not alone. Comment below with one rule you'd write into global governance for biointegrated AI. If you found this thought experiment useful, hit like, subscribe, and share it with one person who needs to think bigger. Join the conversation. EEQ, AIQ, SSQ. Master the trio and shape evolution rather than be shaped by it. I'm Dr. Elena Carruba. Bye for now.